Good morning, pre-calc students. So this week we're going to put together all the different conic sections that we've been working on for the last couple of weeks and look at their similarities and differences. We're going to look at some applications of these conic sections, and then we're also going to look at solving systems where you're looking at one conic section, more than one conic section at a time. So this video, we're going to just kind of go over a summary and an overview of the four different conic sections that we've done, and then also give you a little summary of what we're going to work on this week. So just a reminder, the four conic sections are named conic sections because we're kind of imagining slicing through a cone, and those are the four different shapes that would be made: a circle, parabola, ellipse, and hyperbola. The circle, the definition of a circle is a set of all points that are the same distance away from a fixed point, and that fixed point is called the center. A parabola is the set of all points that are the same distance away from a fixed point, which is called the focus, and a line, which is called the directrix. So again, the focus is inside the parabola, the directrix is outside. And if you think about each of these little line segments here, this blue line segment from the focus to the parabola, and the blue line segment from the parabola to the directrix, those two line segments are the same length, as are the green ones, as are the yellow ones. So every single point along the parabola is going to be the same distance away from the focus as it is from the directrix. An ellipse actually has two focus points, and we say that word foci. So if you take the distance from one focus point, so if you follow this gray line segment, and then you take the other gray line segment, if you added those two distances together, it would be the same length as if you took this yellow line segment and added it to this yellow line segment, and so on for all of them. If you add those distances together, those the distances would be the same. You'll notice that in an ellipse, the focus is inside the ellipse. So the major focus, the distance from the center to the vertex, that is A, and then this distance from the center to the covertex is B. So if the distance from the center to the focus is C, the C is shorter than A. So in order to find the C value, you're going to use this formula, A squared minus B squared equals C squared, because C is going to be smaller than A. So you would need to subtract the B squared to find the C squared. If you look at the hyperbola, it's a similar definition, but it's saying the difference of those distances is constant. So if you went from F1 to P, and then if you subtracted the distance from P to F2, that distance would be the same as if you took, let's say, the distance from F1 to another point here minus that distance. So every single point on the hyperbola, if you subtract the distances from that point to the foci, that difference would be constant. You can imagine with the hyperbola that you could always fit an imaginary ellipse on the inside of the hyperbola. So in this case, the foci are outside of where that imaginary ellipse would be. They're inside the hyperbola. So the C value, the distance from the center to the focus, is larger than the A value and the B value. So to find the foci, you do A squared plus B squared equals C squared. So part of your assignment this week is you're going to create a summary of the four different conic sections. So just as you have all year long, you've created summaries for all of your units, you're going to do a similar thing here. You can do this in your comp book, or you can do it on a separate piece of paper. You can even make it on a larger paper, like a little mini poster. It's kind of up to you. Again, you want to make this summary useful to you. So think about what would be useful for you to put on your summary. It might be also helpful to use color in a meaningful way to show the relationships between like your A, B, and C, or any other way that you think might be helpful. So this is kind of a started summary that I made that might be helpful to you, that kind of just shows the different conic sections and what they look like. I wanted to just highlight a couple of things here. So the parabola, the way you can identify the parabola is that it has either an x squared or a y squared, but not both like all of these other ones do. So that's the easiest way to identify if something is a parabola. If it's an ellipse, you would have your x squared coefficient and your y squared coefficient would both be positive. And if they happen to both be exactly the same, then that's actually a circle. A circle is a special case of an ellipse. The hyperbola has one of those values, the coefficient of x squared or the coefficient of b squared is negative, but not both of them. If both of them were negative, you could actually factor that negative out and it would be an ellipse. And so when you're looking the hyperbola, you're going to determine whether it's vertical or horizontal based on where the negative is. For an ellipse, you're going to determine if it's vertical or horizontal based on whether a squared or b squared is larger. So again, you really want to put all that kind of information in your summary. I would recommend that you include a sketch and then also an example of how to find the center, the vertex, the foci, and the directrix. So this is what we're going to be working on this week. You're going to watch this video, which you're doing right now. There's also another video on applications of conics, which is really interesting to see all the different ways that conics are used in real life. You're going to make your conics summary as I just described, and then you're going to do one more page on the Georgia Virtual Learning website on solving systems of nonlinear equations. So you're going to be looking to see what would happen if you have a circle and a line. How many different places could they intersect? How can you find those intersection points? You can also think about a parabola and an ellipse intersecting. Think about how many different ways that could happen. And so you're going to then work on an assignment where you're going to be looking at all these different conics and seeing where they would intersect. You're going to solve it algebraically and then also connect to what that would look like graphically. Once again, Desmos is a really good tool to help you with trying to check your work or to visualize what those intersections would look like. The assignment is not on the Georgia Virtual Learning site. It's going to be posted on Google Classroom as well as the PreCalc website. You're also going to attend your Zoom meeting on Thursday or Friday and complete the opener that we do there. And all of those things are going to be uploaded onto Google Classroom. So your conic summary, your solving systems assignment, and the Zoom opener. This week, we're going to do things a little bit differently. There's no quiz this week, and there's no review assignment. But there is one additional assignment you're going to do, and it's called Conics in Real Life. And basically what you're going to do is you're going to look around your house and try and see if you can find some conic sections. And you're going to take a picture of at least 2 different types. Try, if you can find some other, circles are the easiest ones to find. So try and stretch yourself a little bit and see if you can find some that aren't circles. But in Google Classroom, there's going to be a slide deck that's going to be there for your period, and it's going to look something like this, where you're going to all upload your pictures to a different slide in that slide deck. So this would be an example for period 1, and essentially, I've given you a little example of what it's going to look like. So here's one for the circle. You would say what the conic is, what it actually is in real life. This is the top of a vase that's in my house, right above my stairway. It's kind of a weird angle. And then you're going to write your name. So here would be an example of a parabola, an ellipse, and a hyperbola. So I've done 4 of them. You don't have to do all 4. You just need to do 2. If you want to do more, that's awesome. So what you're going to do is you'll go to the slide deck and you'll go to the last one that's been entered in there. You're going to just press enter to create a new slide. You will put yours in here, press enter again, and create your next slide, and then your 2 slides will be in there. So you're going to create a collection of all the different, from your class, of all the different pictures of conics around people's houses. You want to be a little bit careful here not to delete anybody else's slide. So if you look on this and someone's slide is highlighted and you press delete, it's going to take theirs away. If you realize you did that, please just undo and take it back. Be really careful so that you're not deleting somebody's work by mistake. And hopefully we'll have a nice collection of pictures when we're done. So again, those are your that's the other assignment for this week. I think that's about it. So once again, watch the videos, make your summary, do page 7 on the Georgia Virtual website, complete that assignment, and do your conics in real life. No quiz this week, no review assignment this week, and we'll see you on the Zoom call on Thursday or Friday. All right, thanks so much. Hope you guys are doing well.